In this video, we are going to talk about section 9.4. Here we are doing hypothesis tests for one population mean when sigma is known, right? Sigma being the population standard deviation. Okay, so in section 9.1, we talked about finding the null and alternative hypothesis and determining if the test is two-tailed, left-tailed, or right-tailed. And then in section 9.3, we talked about computing p-values and how to decide whether or not to reject the null hypothesis or do not reject, okay, the null hypothesis. All right, so in section 9.4, basically we put all of those things together. And first, before we get into the examples, we want to talk about the procedure for the one mean z-test. All right, and so the purpose is to perform the hypothesis test for a population mean mu. And the assumptions that have to be satisfied to be able to use this test. Number one, the sample has to come from, has to be a simple random sample, right? The population has to be normal or the sample size pretty large. And then the population standard deviation sigma has to be known. Okay, so the null hypothesis is always going to have this form, h naught, right, mu equals mu naught, and the alternative hypothesis is going to be h sub a, right, and that's either going to be a two-tailed test where mu is not equal to some value, mu naught, or mu zero, however you want to say it. A left-tailed test is that mu is less than mu zero, and a right-tailed test is that the population mean mu is greater than mu naught. So those are the three forms. That's also how you have how you tell whether a test is two-tailed, left-tailed, or right-tailed. You're going to have to get that information from the statement of the problem itself, and in section 9.1 is how we explain is explanation on how you do that. So if you haven't watched that video, you probably better go back and watch that video first. All right, step 2 is to decide on the significance level alpha. You don't really have to do that. That's going to be given to you in the statement of the problem, so that's not a huge deal. Next up is to compute the test statistic, and so that would be z equals x bar, that's the sample mean, minus mu naught, that is the number here in the null hypothesis. And that's divided by sigma, the population standard deviation, divided by the square root of n, which is the sample size. Okay. All right, so you'll get some number for that, and that's the number that you get is this z0 in this picture here. So step 4 is use table 2 to obtain the p-value. In the material on section 9.3, we went into detail about how you would obtain those p-values. So again, if you haven't watched that video, you need to go back and watch that and work those problems before we get before you get to these problems. Okay. So that is step 4. Use table 2 to obtain the p-value. And step 5, you're going to make the decision about whether or not to reject the null hypothesis. If your p-value is less than or equal to the significance level, alpha, then you're going to reject the null hypothesis. If your p-value is greater than the significance level alpha, then do not reject the null hypothesis. All right, and then you are going to interpret the results of your hypothesis test. All right, and again, there's two cases. Case 1, right, you rejected the null hypothesis, right? The conclusion is going to be, right, that the data do provide sufficient evidence to support whatever the alternative hypothesis is. In other words, if we reject the null hypothesis, the data is supporting, all right, it has sufficient evidence to support that the alternative hypothesis is true. Okay. All right, and then if you fail to reject or do not reject, right, then you conclude that the data do not provide sufficient evidence to support the alternative hypothesis. So in your conclusions, right, it's going to be stated in terms of the alternative hypothesis either way. All right, so make sure that you pay attention to this. Okay, If you reject, right, the null hypothesis, then your conclusion is going to be these words right here. The data do provide sufficient evidence to support, and then whatever the alternative hypothesis is. Okay, that part, the alternative hypothesis, is going to vary from problem to problem, but it's always stated in terms of the alternative hypothesis. Okay, if you do not reject, right, then your conclusion is going to be this: the data do not provide sufficient evidence to support, right, and then whatever the alternative hypothesis is. Okay, all right. So that's the procedure. The first example that we are going to do is problem 978, right? The sample mean, the sample size, and population standard deviation are all provided here. It says use the one mean z-test to perform the required hypothesis test at the 5% significance level. All right, so let me just check to see if that looks okay, other than being really, really big. Okay. All right, let me erase that. Okay. All right, so our null hypothesis, right, and our alternative hypothesis are given to us. In this case, all right, so our null hypothesis is that the population mean equals 22, right? The alternative hypothesis is that the mean is less than 22. Okay, all right, so going back here, right, that's step one, right, to know your null hypothesis and the alternative hypothesis. Our alternative hypothesis is of this form, so it is a left-tailed test. So that is step one. Okay. Step two, right, is to know your significance level. So if we go back to the statement of the problem, our significance level is at the 5% significance level. So as a decimal, that would be 0.05. All right. So that is step two. Step three is to compute the value of your test statistic. So our test statistic is z equals x bar minus mu naught over sigma divided by the square root of n. Okay, and so this is our formula, right, for the test statistic, and we need to compute that out. So looking at our values here, x bar is 21, right? Mu naught is this number over here, right? That's in the null hypothesis. Sigma is the population standard deviation, and that is given as 4. And the sample size is 32. So it's going to be 4 over the square root of 32. Okay. So we will need to get that value. All right, so 21 minus 22. Divided by 4 divided by the square root of 32, right? So that comes out to be minus 1.41, right? Let me do that. All right, so we're done with that step, right? We have calculated the value of the test statistic, okay? So on to step 4. Right, use table 2 to determine the p-value. All right, so we are doing a left-tailed test, right? So this is the test that we are computing right here. Okay. And so what we're going to do, right, is to find our p-value, is find the area underneath the standard normal curve, right, to the left of minus 1.41. So to the left over here. Okay. So go to table 2 and look up minus 1.41. So minus 1.41 would be right here. So our p-value is going to be 0.0793 for our p-value. Okay. All right. Next step, right, is then to compare your p-value to the significance level. All right. So looking at ours, right, the p-value is 0.0793. Alpha is 0.05. All right, and so we're just looking to see which one of these is bigger, and we notice, right, that the p-value is bigger, right? So the p-value is bigger, we do not reject. Oops. The null hypothesis, okay? So that is this step right here, step 5. All right, step 6, right, is to interpret your results, right? And so we did not reject the null hypothesis. So our conclusion, right, is that the data do not support or do not provide sufficient evidence to conclude that, and then whatever the alternative hypothesis is, right, and that is mu is less than 22. Okay, so that would be our conclusion. And notice, right, the thing to notice here, that's the exact words, right, that it says right here. The data do not provide sufficient evidence to support, and then the alternative hypothesis, whatever that may be. Right here, we don't have any context. They just gave us this, right? So we just say that mu is less than 22. Okay. All right, and that's all there is to this one. So in the next few, we'll do some more examples of this, and we will separate those out into subsequent videos.